So can you see my screen?
Yes, sir.
Okay.
Yes, sir.
Okay, thank you. So today we will start with gyroscope, right? So actually gyroscope means whenever you will have actually it has come from the gyroscopic effect. We will see what is gyroscopic effect. So gyroscopic effect will come into picture whenever you will have any rotating element. Suppose this is a disc, right? It is having rotation about this particular, let us say, x axis. Let us say this is y axis. Here if this disc is rotating about x axis, right, then this will be the axis of spin for this particular element, right? Now if this particular rotating element will have any rotating motion about this particular y axis, right, which can be considered as axis of precession, right, then what will happen is whenever this particular uh, disk will rotate about this y-axis also, in addition to its spin axis, there will be a generation of angular acceleration, right, and that angular acceleration will try to move the object or the disk in a particular direction. That direction will be in whatever this third axis is remaining, right, whether you can consider it as normal to the plane of this particular screen. So it will, that particular couple is known as active gyroscopic couple, which will try to rotate that particular object about this third axis, right, that is known as active gyroscopic couple. And whenever active gyroscopic couple will be there in the picture, there must be reactive gyroscopic couple also, right, as you are having centrifugal acceleration and centripetal acceleration, right. So if we first discuss about the angular velocity and angular acceleration, and then we can go into the discussion of how it will going to affect different application, right, means where we are finding this kind of situation where rotating elements are also having rotation about any other axis. Like here, as we discussed, this disk which is spinning about x axis may have the rotation about this particular axis y also, right. So let us first see this angular velocity and try to understand how you will represent this angular velocity. So in the given figure, what is mentioned is whenever you are viewing from the A side, right, you are having this AB as a rotating shaft on which a disc is mounted. So whenever you are viewing from A and this direction of rotation is clockwise, right, so this angular velocity will be represented as three main things, that is the magnitude of velocity, direction of the axis of rotor, and the sense of rotation. So once you see it from the A side, you can see that the this disc is moving in the clockwise direction, right. So how will you represent that? So for that you can take scale, right, and represent the magnitude of that particular angular velocity. So this AB vector is actually showing magnitude of that particular angular velocity omega. Now the second thing is how you are going to plot the direction. So direction of that particular AB vector will be parallel to this axis AB, parallel to AB. That will be the direction, right? So when you are drawing this vector, what you know is the magnitude and direction. So let us say magnitude you have scaled and you have drawn this vector AB, right? Now the remaining thing is sense of rotation. So how will you decide whether it is rotating clockwise or anti-clockwise? So this will be decided here based on that simple that right hand screw law only. So what will happen if you are going to rotate in this clockwise direction, then it will go away from you, and if you go for anti-clockwise, then it will come towards you. Means here from A, if you are rotating it in clockwise, it means it will go away like from A to B. So that is why it is mentioned here, right? Similarly, if you change the direction of rotation from clockwise to anti-clockwise, then also what will happen, this direction will change from B to A, right? Magnitude is not going to change, but this direction of that arrow is going to change, and similarly here it will be anti-clockwise and here it will be clockwise. So this is how angular velocity is being represented, right? One second. Okay, right? So this is how you are having your angular velocity. So once you are done with this angular velocity, then you can come for this angular acceleration. Now as we have seen, right, here actually this x, z and y, they have mentioned like that. We have seen that x, y and z, this one, whatever. So this is basically, x is, can anyone say what is x axis? Anyone can unmute and say?
Angle of spin.
Ang-
Axis of spin.
axis of spin. Okay, good. Axis of spin. Similarly, what is this z axis?
Active gyroscopic couple.
Axis,
Sorry, axis of precision.
axis of precision. Okay.
Axis of precision.
Yes, 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 correct. So here also what is happening, see, you are having this rotating disc which is having spin about this x-axis, and it is rotating about this z-axis. So that z is axis of precision, and when it is going to move in that direction, what is going to happen is an angular acceleration will take place, and because of that you will have active gyroscopic couple, and due to active gyroscopic couple, reactive gyroscopic couple will will be generated. So here if we only discuss about it, this angular acceleration, then you can see the omega has changed from omega to this omega plus delta omega. So what will be the different component of this particular vector AB, because that will be your angular acceleration, right? So this it is having horizontal and vertical component. So if you see horizontal component, right, here horizontal component is this omega plus delta omega cos delta theta, right? See, this is delta theta, right, and this whole will be OC whole will be omega plus delta omega cos delta theta. You are finding AC, right? So you will subtract omega from this, correct? So this is how you will have this component AC. Now rate of change will give you the angular acceleration for that particular component, right? So if you find this rate of change, then it will be this omega plus delta omega cos delta theta minus omega upon delta t, right? So here, by considering that delta theta is very small, right, almost 0, so cos 0 will be 1. So in that case, omega plus delta omega minus omega upon delta t, cos delta theta will be 10 to 1, right? So you will have this particular component as delta omega by delta t, right? It will be almost 0 only, you can consider this, right? So once you consider this, you can have this component as d omega by dt, right? So this is the horizontal component for this particular angular acceleration. Now you will have one more component, that is a vertical component. So for that, this vertical component is CB, right? If you observed in that figure, then it is nothing but omega plus delta omega sine delta theta, right? And divide by dt if you are taking that rate of change. So here what will happen, if delta theta tends to 0, then sine delta theta will be tend to delta theta. So here what will happen, this omega delta theta by delta t, this delta omega delta theta by delta t will be very small, so you can neglect that term. So only this term will be there, omega delta theta by delta t. So it is nothing but omega d theta by dt, right? So this is how your total angular acceleration alpha will be given by both the components, that is d omega by dt plus omega d theta by dt. So this is how you will have this both the components, right, of your angular acceleration. So this particular component is responsible for change in magnitude, right, while this other component is responsible for change in the direction. Right, so this is how you are having this angular acceleration. Now if we go for the next, this gyroscopic couple, then here as we have discussed that this particular motion is going to generate a couple which will try to rotate your component about the remaining axis, that is this third axis, right, OY. So it will try to rotate your component about this particular axis OY. So here that active gyroscopic couple, one second. So here this active gyroscopic couple will try to rotate or try to rotate this particular component in this clockwise direction, right, when you are viewing from A, because it is going away from A to B. So it will try to rotate your component or your whatever rotating element is there in the direction of clockwise in the vertical plane. So AB is applied this what we can say active gyroscopic couple, and B dash A dash is the reactive gyroscopic couple. So because of reactive gyroscopic couple, your this component will have different effects that we will discuss, right? Now how can you quantify this gyroscopic couple? So for that, if you see, you are having the change in angular velocity. Change in angular velocity is EB, as you can see mentioned here. So which is nothing but omega into delta theta. Now this is your change in angular velocity, right? So your angular acceleration means rate of change of this angular velocity, if you will take, then it will be omega delta theta by delta t, right? So what you will get this omega delta theta by this delta t is, this omega is that spin of this rotating component. As you can see, this omega is the rotating speed or rotational speed of the means of the spin with which it is rotating about x-axis. Now this delta theta by delta t is what? It is the angular motion of this particular axis of spin about this precession axis, right? This is precession axis and this is axis of spin. So this delta theta by delta t will be the rotation about this precession axis, as you can see here, right? So this delta theta by delta t is angular velocity of precession, angular velocity of precession, right? So once you have this angular acceleration with you, now you can write about this acceleration torque, right? So this torque is I into this angular acceleration. So alpha is here, this angular velocity of precession can be considered as omega p, right? This delta theta by delta t can be considered as omega p. So you can write it as I omega p, right? So this is how you are having this magnitude of gyroscopic couple, right? This is your gyroscopic couple, right? So this is how you can calculate the gyroscopic couple. Now if we go for different cases in which you will find this, so if you see the effect of this gyroscopic couple on aeroplane, then here different cases are given. So if you see here, then the first case is when viewing from rear, this fan or rotating element is clockwise rotation. So it is mentioned in this figure B what is going to happen in this case, right? So if you focus on figure B, then you will have angular velocity in this direction. As it is clockwise, you use that right hand rule, right? So it will be in this direction. Now when viewing from rear in clockwise direction and you are taking a left turn, right? If you are taking a left turn, means your aeroplane is taking a left turn. 1 second. So if it is taking a left turn, then here see, they have shown you this plane of spin, then plane of precession, and plane of couple, means your whatever the gyroscopic couple, right? So whenever this aeroplane is going to take a left turn, right, what will happen is this will be the active gyroscopic couple AB, which is mentioned here, right? So if AB is gyroscopic couple, then active gyroscopic couple will be clockwise, right? So if active gyroscopic couple is clockwise, right, then reactive gyroscopic couple, this is active gyroscopic couple AB, and this A dash B dash is reactive gyroscopic couple. So this is clockwise, as you can see in this case what we are discussing. Then this must be counterclockwise. And what is going to happen if counterclockwise what we can say torque is going to act about the third axis, as we have discussed? So if you can imagine, then if counterclockwise force is going to counterclockwise couple is going to act on your aeroplane while taking a left turn, right, there is an axis which is coming out of the plane, right? So if that particular axis, about that it will be in this counterclockwise direction, then what will happen? It will try to raise the nose and tip the tail, raise the nose and dip the tail. See, this is very important thing. If anyone is having doubt in this, then you can please ask, because if you are going to understand this one thing, then all other cases you will be easily able to understand. And if you are not getting this very first case, then it will be difficult for you to understand what we are going to discuss further. So is there any doubt in this particular first case? Hello.
Sure. Can you repeat the left hand part?
Sorry.
The situation when the plane is taking the left turn.
Situation is when a plane is taking a left turn, huh?
Yes, the A part.
A, A part, A is actually a simple figure, right? A is not any case. The figure A shows you the what we can say the position of your aeroplane. So this is rear and this is front, and in front you are having this fan, right? Or you are having various rotating elements in your engine of any what we can say this whether it is aeroplane or ship or any automobile, right? So you are having various rotating element, right? So here you are having a rotating element in your aeroplane which is having clockwise motion when you are viewing from the rear, right? So based on that, this figure B is our this 1A case. 1A case is when viewing from the rear, clockwise rotation is there, and your this particular what we can say this aeroplane is taking a left turn. So due to this left turn, this active gyroscopic couple is trying to generate in the means it is generating in clockwise direction about the third axis, which is coming out of the plane of paper, right? So it is generating in clockwise direction. So the reactive gyroscopic couple is going to generate in the clockwise direction, sorry, counterclockwise direction. And when this reactive gyroscopic couple is going to generate in counterclockwise direction and it is acting about this perpendicular axis to the plane of this paper, then what will happen? This nose it will try to raise the nose and what we can say try to deep the tail, right? Are you getting
Yes, understood.
right? Understood,
Yes,
right? So here also I guess not all the three axes are it is isometric and that also. So basically you are having this this third axis which is coming out, right? Here your component or whatever this plane is moving, right, in this direction with rotating element having rotating motion clockwise viewing from the rear, right? So what is going to happen when it is going to take a left turn is shown here in this figure. So when it is going to take a left turn, this particular AB vector is this acceleration vector which is in that direction because it is generating clockwise couple about this axis. This is the third axis about which it is going to generate the couple, that is active gyroscopic couple. Now if you see this particular clockwise couple will try to lower the nose, but reactive gyroscopic couple is there, reactive gyroscopic couple is there which is going to raise the nose and dip the tail. I guess from this figure you can understand. I don't know whether
yes, sir.
so everyone is clear with this.
Yes, sir.
Okay, so now we can go for the second one, right? If you go for the second case in the same one, which is when you are viewing from the rear, clockwise rotation is there. Now if you take right turn, then what will happen? This particular figure is there for this case, this figure is there for 1A, right? Here this figure is there for 1B. So what is going to happen? Can anyone tell?
Nose down and tail up.
Okay, but you understood, right, why it will be like that? Because you will have what it can say, the spin axis is going to rotate about the precession axis in this way, and because of that active gyroscopic couple will be in anti-clockwise direction, so reactive gyroscopic couple will be in clockwise direction, right? Here
Sir,
active, yes.
sir, the reactive gyroscopic couple is rising the effect of nose dip and tail rise.
Sorry.
The reactive gyroscopic couple is initiating the nose rise.
In the first case,
Yes,
in the second case it will deep the nose.
yes.
Here it will deep the nose, right? And it will raise the tail. Okay, correct. Okay, now, yes.
अ, बस सर यही बोल रहे थे कि हाँ.
Okay, now let us go for the second case, in which when viewing from front, sorry, when viewing from rear, what you will have is clockwise, we have seen, right? So now if you have anti-clockwise or counter-clockwise rotation, so if you are viewing from rear and you are having counter-clockwise direction, then the vector will be towards you, right? Because you are here, viewer is at the rear, right? And it is viewing from this and anti-clockwise direction, so it will be towards the viewer. If it is clockwise, then it will go away from the viewer. So here this will be the second A. What was A? A is left turn, right? So what is going to happen in this case? Can you see here what is happening? Anyone?
Nose rise
Nose
and tail dip.
nose nose down and tail rise.
Yes, the same thing will happen, because see here whatever this active gyroscopic couple is generated, it is in which direction? It is in counterclockwise direction, right? So the reactive is in clockwise direction. This is reactive, right? And this is active. So this is how here the same effect will be there as 1B. It will deep the nose and raise the tail, right? And in case of 2B, while taking a right turn, what will happen? Opposite to it, right? Means same as in 1A. It will raise the nose and deep the tail. Okay, so is this clear to everyone? Hello? Hello?
Yes, sir.
Okay, okay. So now let us go to the next, that is gyroscopic effect on the naval ships. So for naval ships, first you have to have idea that what are the different terminology. Means stern means the back side, bow means the front side. Then in that, here you are given that rotor, as you can see rotor is mentioned here. Now what is happening in case of this particular naval ship is, if you see this, so this may be the rotor. So what is happening in case of naval ship is, whenever it is steering, right, whenever your naval ship is going to steering towards left or right, it will be the precision axis, right? But your naval ship is also pitching, right? So in case of pitching, what is happening, it will have that vertical up down motion about this particular axis. For pitching, this will be your what we can say, precision axis. Right, for pitching, this will be precision axis for steering. Now one more thing is there in case of naval ship, and that is rolling. So rolling will be there about the same axis of spin. So what is going to happen in this case is there will be no gyroscopic effect. There is no gyroscopic effect because axis of precision and axis of spin is same. So there is no gyroscopic effect in this particular case, right? So this is how you can have your what we can say, different precision axis when you are discussing about this ship. So now if we see what we can say, different case, then as you can see here they have mentioned regarding this steering, and here they have mentioned regarding pitching. So what will happen in case of this what you can say, steering? So if you see here, when viewing from the rear, what will happen, this is clockwise direction and left turn, as you can see, right? So what will happen, can anyone tell? In this 1A, it is similar to that what we have discussed, viewing from the rear and in clockwise direction and taking a left turn. So what will happen to the bow and stern in this case?
Bow will rise, stern will down.
Okay, correct. Similarly, in case of this right turn, what will happen? Opposite to that will happen, right? Correct? Hello.
Yes, sir.
Okay, and similarly for pitching also, if you see what is going to happen. So here in pitching, if you are viewing from this direction, when this bow is rising, means bow is rising means in case of pitching, as I have told you, it is the what we can say, when if you have your this ship on this axis, then it will rotate about this axis, means it will go up and down like this, right, on both sides, like this, right? So it is mentioned that when bow is rising, what is going to happen, and then bow is lowering, what is going to happen. So actually in case of pitching, what is going to happen is your this what we can say, the gyroscopic couple needs to be calculated in case of pitching. See, we are assuming that there is simple harmonic motion only, assuming SHM, and as you know, SHM is governed by x is equal to x sine omega t, right? So here, if you consider for pitching of this ship, you can take this relation theta is equal to this phi sine omega 0 t, where phi is the maximum angle, right? As x is the maximum amplitude in that particular case. So similarly, this omega 0 is the angular velocity of SHM. SHM, right, into 2 pi by whatever time period you are having. So this is how you can have this displacement in case of this pitching motion. So once you have this displacement, from that you can go for angular velocity of precision, that is what d theta by dt. So d theta by dt you can directly write as 5 omega 0 cos omega 0 t. Right. Now once you have calculated this d theta by dt, right, then this will be maximum when cos omega 0 t will be 1, right? When this will be 1, at that point it will be maximum, right? Now in case of this pitching, if you want to calculate the gyroscopic couple, so it will be again I omega p, and as you have seen that omega p is nothing but pi into 2 pi by time period. So this is how you can calculate this gyroscopic couple in this particular case, right? You can calculate angular acceleration also and maximum angular acceleration also, as you have calculated angular velocity on the upper side. And finally the rolling we have already discussed that there is no gyroscopic effect in rolling. So this is about your what we can say aeroplane and your this naval ship. Apart from that, automobile is also having this gyroscopic effect. It will not go into the depth, but a little bit idea you must have about this also. Whenever your vehicle or automobile is there, in that also this gyroscopic couple is going to affect. So here, as you can see, you are having this rotating wheel, right? In this automobile you are having this rotating element as wheel and some engine parts you are having, right? For engine rotor you will have that. So these are two different rotating elements, right? So now if you see in case of this automobile, what you will have is you will have this 4 rotors, right? If you consider the wheels, then 4 wheels are there, right? And each of them are suppose generating I omega p, right? So due to this rotating wheel, you will have this gyroscopic couple as 4 I omega p, means I omega w is for wheel and this is for precision axis. It means this vehicle is having this as axis of spin, let us say, and there must be certain axis, right, about which it is taking this turn. So there will be some radius to the center of this axis through which it is taking turn. So this will be the axis of precision in that case, right? So that will be the axis of precision, and it will have some capital radius r, let us say. And in case of this wheel, let us say that wheel radius as small r, here also will have some radius, right? So let us say wheel radius as small r and this radius of curvature as capital R. So and for both omega w and omega p, your this vehicle's linear velocity v is going to be considered. So if you consider linear velocity, then what will happen is omega w will be v by r and omega precision will be v by capital R, right? So once you have this idea, then your this gyroscopic couple due to rotating wheels will be 4I v square divided by r into r. So this is how you will have this gyroscopic couple. Now where this I will be the moment of inertia of this wheel only, right? Mass moment of inertia of wheel, because the wheel we are considering as a rotating element, right? Now once you have this particular gyroscopic couple due to wheel, then you also have to have idea about due to engine rotating parts. So because of that you will have one more gyroscopic couple, that will be IE omega E omega P. So those engine parts will be having some mass moment of inertia. Then this omega E is rotational speed of that engine element, which is related to speed of wheel with this gear ratio. Gear ratio, right? Because we know that gear ratio is equal to what? This omega E by omega W. That is why I have replaced this omega E with G omega W, and omega P is there, right? So now once you have this both the gyroscopic couple due to engine rotating parts and this wheel, sorry, this right? So due to that wheel which is rotating and due to parts rotating in engine, due to both you are having gyroscopic couple. So if you are going to combine, then what you will have is Cg will be Cw plus or minus Ce. Cw is due to that wheel and Ce is due to rotating parts of engine. Right, so this is how you are having this final gyroscopic couple. Now what you can do is you can also calculate the force due to this particular couple, Cw and Ce. So for that here you are provided this distance, right? So this if you consider forces on outer wheel, see this is your vehicle and it is taking left turn, so this will be considered your outer wheels, right? And this side your inner side, so inner wheels, right? So if you see that because of this particular gyroscopic couple on outer side you are having that see this particular force which is generating this gyroscopic couple will be acting downwards on your whatever this outer wheel, right? Let us say this Cg by W, right, which is acting on outer side and it is acting downwards, right? So and if it is acting downwards on the outer wheels, then it must be acting upwards in the inner wheel side. So here Cg by W is downwards, let me put simply this sign, right? And on this side it is Cg by W upwards on the inner side. Again it is divided between two wheels, so on each wheel I can write Cg by 2W and here also Cg by 2W, right? So this is how you are having Cg by 2W on each wheel. On outer side it is downward and on inner side it is upward. Now once you have this, then what is going to happen is one more thing here you need to take care about is, and it is this centrifugal force, right? So how this centrifugal force is going to affect this particular reactions and all. See, as we have discussed, this vehicle is taking turn about a particular radius r, right, which we have considered as precision axis, and from that distance we have considered it as r. So if you are having any precision axis about which your vehicle is taking turn, then it will experience this centrifugal force also. and this centrifugal force will then be mr omega square, and omega will be precision axis omega, right? Mr omega p square will be there. So here as we know, omega p is nothing but v by capital R. So you will have this mr v square by r square. It will be, I guess, written as mv square upon r, mv square upon capital R. That will be the this centrifugal force. Mr omega square is centrifugal force, and the couple, if we are going to consider centrifugal couple, if we are going to consider centrifugal couple, then it will be mv square by r into h. As you can see here, the distance is given, right? And because of this centrifugal couple also, you will have that same cc by 2w on your will, cc by 2w reaction on your will, right? So again, on outer will it will be downward, and on inner will it will be what, this cc by 2w, right? So this is how you are having this particular two couples, and because of that you will have some forces which are generating this couple, and in order to what we can say, in order to nullify, or we can say in order to keep your vehicle in balance, there will be reaction provided at the wheels in the opposite direction to this force which are generating these couples. So that is why this reaction at the wheel is calculated, right? So this is how you are having this centrifugal couple and this gyroscopic couple in case of this four-wheeler automobile, right? Similarly, it is going to affect two-wheeler also, right? So in case of two-wheeler, actually what is going to happen is, as you can see here, this IW cos theta is the only actually component which is along the spin axis, right? And if you have observed, whenever a vehicle or two-wheeler is taking a turn, we are we are providing certain angle, as it is mentioned here, this angle, right? We are tilting our two-wheelers by some angle. In our daily life it is not that much observable, because we are reducing the speed. So that is why it is not that much observable in our daily life. But if you have observed those bike race and all, in that biker is not allowed to reduce the speed while taking a turn. So whenever those bikers are not allowed to reduce the speed, what they are going to do is they are going to give this tilt angle in order to achieve equilibrium, right? Because otherwise this couples which are generated may overturn or may skid the vehicle. So that is why you also have to idea about this angle theta, right, which is also known as angle of hill. You are providing for avoiding the skidding of vehicle, right? You have to see what is the angle which must be provided in order to avoid the skidding of this two-wheeler while taking a turn. So here IW cos theta is, as I have discussed, it is your whatever that component which is on the axis of spin. So if you write gyroscopic couple for this two-wheeler, then you have two wheels. So for two wheel it is I omega omega W, and one is for that engine parts, right? And as we have seen, cos theta of this particular component will be considered, and then you will have some omega p about the precision axis, right? So here again omega w and omega p, as we have discussed, it will be this v by r and v by capital R, where v is the linear velocity of vehicle, r is radius of wheel, r is radius of wheel, and this r is the radius of curvature, or radius what we can say, curvature on which vehicle is taking a turn, right? So this is how you are having that gyroscopic couple in your two-wheeler. Now if you, and this omega e, sorry,
सर ये आई cos थीटा के बारे में एक बार बताइएगा, ये आई ओमेगा cos थीटा जो लिखती है लेफ्ट हैंड साइड में पी के ऊपर.
yes. So see, as you can see here, this particular what you can say spin axis is actually this dashed one. It is going to change, right, its direction, because you are tilting your vehicle, right? Here if you can see in the figure, right? So what is going to happen is, in case of your plane, or you can say aircraft or naval ship, this axis of spin is not going to tilt whenever you are taking a turn in case of aircraft, or steering in case of naval ship. This axis is not going to have any tilt, right? There is no tilt in the previous two cases which we have discussed, right? Or previous three cases. In that four-wheeler also you are not having any tilt of this axis of spin. Are you getting what I am trying to say? Yes.
तो ये
So here that axis of spin is going to have tilt, so that is why we are considering the component which is in that particular direction. Are you getting?
yes
Hello.
sir, yes sir.
Okay, okay. So that is why that IW cos theta is considered, because you are going to have axis of spin has tilt by an angle theta in case of this two-wheeler taking a turn. So here also left turn is there, right? If you can see in the figure, right? So now once you what I was telling is, this omega e also, you know, you can put it as g into omega w, right? So if you put all these values, then your final gyroscopic couple will come like 2iw plus GIE v square by r into r, sorry, here v square by r into r cos theta, right? So this is how you will have your gyroscopic couple in case of two-wheeler, right? So here in case of this two-wheeler also, you are having that centrifugal couple, right? And here in case of two-wheeler, that centrifugal couple will be I guess here it is not shown in the figure, but in that case what is going to happen is, for that centrifugal couple it will be mv square upon r into cos theta. That component is going to generate the what you can say centrifugal couple. Mv square upon r cos theta is the force which is generating that couple, and h is the distance. So this force into distance will give you the centrifugal couple. Now if you see this both, this gyroscopic couple as well as this centrifugal couple is going to try to overturn this or you can say try to skid the vehicle. So when this both is going to try to skid or overturn the vehicle, GC plus this CE, then you will have a restoring couple, right? This restoring couple will try to keep the vehicle in position and avoid skidding, and that component will be this sorry, mgh sine theta is the component which is trying to restore the what you can say mg sine theta will be the force on the h distance. So once you are going to apply this equation, this gc plus ce is equal to mg sine theta into h, it will give you the value of theta, and when you are going to have this theta, you can avoid skidding of the vehicle, right, to avoid skidding of the vehicle. So this is how you are having this different components where you are using this gyroscopic couple. So can we go for questions? Hello.
Yes, sir.
line
So here, as you can see, a car is moving on a curved horizontal road of radius 100 mm, sorry 100 meter, radius 100 meter with a speed of 20 meter per second, right. The rotating mass of the engine have an angular speed of 100 radian per second in clockwise direction when viewed from the front of the car. The combined moment of inertia of the rotating mass is 10 kg meter square. The magnitude of the gyroscopic moment in Newton meter is. Can you try this? Hello.
200.
Sorry.
Is the answer is 200?
Let me check. And others also, are you getting the same answer? Hello. All of you are getting the same answer? Please type in your answer in the chat box, then we will see what is the correct answer. Okay, two of them are getting that answer. Anyone else? Hello.
Yes, sir.
So okay, all of you are getting the same answer, right? 200. Yes. So how it will be means whatever, whoever has got the answer here, what is given is 1 second. I is given as 10 kg meter square, right. Omega is given as 100 radian per second, and omega p will be V by R. What is V? V is given as 20 and R is given as 100, right. So it will be 20 by 100 radian per second. So once you have all this, I omega omega p will be your gyroscopic moment, right? A gyroscopic couple will be I omega omega p. So what is I? 10, then omega is 100, then this 20 by 100, so it will be 200, right, in Newton meter. So this is how you are having your gyroscopic couple. Right, if you go for the next, then here the rotor of a turbojet engine of an aircraft has a mass 180 kg and polar moment of inertia 10 kg meter square about the rotor axis. Now the rotor rotates at a constant speed of 1100 radian per second in the clockwise direction and viewed from the front of the aircraft. Now the aircraft, while flying at a speed of 800 km per hour, takes a turn with a radius of 1.5 km to the left, right. Then the gyroscopic moment exerted by the rotor on the aircraft structure and the direction of motion of the nose when the aircraft turns R. So again you have to calculate that I omega omega p, and you have to also mention the what will happen to the nose. So can you try it by yourself? Type in your answer in the chat box, whatever option you are getting. Can you please try? Hello.
Yes, sir, solving.
Okay, try and solve it.
Sir, is the option A is correct?
Option A. How many of you are getting that?
इतना तो पक्का है कि नोज डाउन
Hmm.
मोमेंट ऑफ इनर्शिया और उसकी वजह से थोड़ा
Sorry.
सर पोलर मोमेंट ऑफ इनर्शिया
It will be same. You can consider here I. I only.
सर पोलर मोमेंट ऑफ इनर्शिया एंड मास मोमेंट ऑफ इनर्शिया सेम है
See, here we are considering it as I only, whatever for this particular problem.
then sir what is the need of giving mass
Actually, there is a difference that we will discuss, but for now you can consider this I as 10 kg meter square. So once you consider this I as 10 kg meter square, right, and then omega is given as 1100 radian per second, right, then R is given as 1.5 kilometer, that will be 1500 meter, right, and what else is given? This V is given as 800 kilometers per hour. So you need to convert it into meter per second. So 800 into 1000 per 3600, that will give you this V. So what is this? Can anyone tell?
222
Okay, okay. So once you have all this data with you, then omega p can be calculated as V by R. So what is omega p then? Can anyone tell?
Sir, 0.1481.
Yeah, so 0.148, right? 0.14, 0.14, whatever you can take, that is radian per second. So once you have all this data, I, omega and omega p, then you can calculate your gyroscopic couple. So when you put all this value I, omega, omega p, your gyroscopic couple will be 1629.629 Newton meter, correct? So it will be one of these two, right? Either this or this. one of these two. So now we need to check what will happen to the nose. So let us see again by this particular given condition. What they have given is you are having this aeroplane and rotating part will be on this axis of spin. Then rotor rotates at constant speed. What is given is in the clockwise direction when viewed from the front of the aircraft. Clockwise direction when viewed from the first and from the front. If you are considering this as front, right, and this as rear. Now when you are viewing from front, what is happening is it is clockwise. So if it is clockwise, then it will go away from the viewer. If you are going to see like this, then it will go away from the viewer, right? Now vehicle is flying at a speed of 800 kilometers, right, per hour. Now what is going to happen? It is going to take the left turn, right? So when it is going to take a left turn, then what is going to happen is you will have this one more couple generated, right, like this, and this will be the active gyroscopic couple. So this will be the reactive gyroscopic couple, right? And when this will be the reactive gyroscopic couple, then your nose will go down. So your B is the correct answer, right? So all of you are getting the same?
सर ये इफेक्ट करता है बॉडी के मूवमेंट पर.
Sorry?
कपल.
Sorry?
सर द कपल
Couple?
on the body is reactive couple or the active couple.
Reactive couple, reactive couple. This is reactive couple which is going to affect, right?
एंड सर मतलब इसमें एक चीज और कंफ्यूजन थी सर कि ये जो पोलर मोमेंट ऑफ इनर्शिया होता है ये मास मोमेंट ऑफ इनर्शिया के दुगना होता है अगर सर्कुलर क्रॉस सेक्शन है तो इस वजह से थोड़ा कंफ्यूजन था.
Actually, for most of the cases, it is similar only, but there is a difference between mass moment of inertia and polar moment of inertia, right? That we will see, right? But for now, it is this only. Whatever we have considered that I, right, is the same as this 10 kg meter square. Okay.
ओके सर.
So here this thing is clear, right, to everyone? This nose will go down because the reactive couple will try to up the lift of this particular tail, so the nose will go down, right? So this is how, because see here this reactive couple is in this direction, it means about this particular third axis it will be in it will be in this clockwise direction, right? That is why it is going away in this particular direction, right? So this is how you are having this nose down and this tail up and nose down because of this particular reactive gyroscopic couple, right? So the next is this one. Here what is given is a uniform disc with radius r and a mass of m kg is mounted centrally on a horizontal axle of negligible mass and length of 1.5 r. The disc spins counterclockwise about the axle with angular speed omega when viewed from the right hand side bearing q. Now the axle presses about the vertical axis at omega p is equal to omega by 10 in the clockwise direction when viewed from above. Let Rp and Rq be the resultant reaction forces due to the mass and the gyroscopic effect at the bearings P and Q respectively. Now assuming omega square r is equal to 300 meter per second square and g is equal to 10 meter per second square, the ratio of the larger to the smaller bearing reaction force is, this you have to calculate. So can you try this? Hello.
Okay, sir. Okay, sir. Trying.
So here as per the given condition, if we see that active gyroscopic couple will be I omega omega p, right? And as you can see, you are having this particular axis of rotation is given, right? Then it is having this rotational motion about this precision axis, right? And because of that you will have some reactive gyroscopic couple generated, right, which will again be in this direction. So
Sir, I am getting 1.5.
1.5. No, let us see here. Active gyroscopic couple is this I omega omega.
Sir, I am getting
I'm getting
3.
correct. So let us see. Now I is mr square by 2 here for rotating this. Omega is given as omega only, and omega p is given as omega by 10. So your this particular I omega omega p can be written as mr square by 2 into 1 second. Mr square by 2 into omega by 10. So here you will get m omega square r square by 20, right? So once you get this reaction force at this bearing due to this particular gyroscopic couple will be this rp, let us say, right? That will be this couple divided by this is the couple, right? This particular couple divided by the distance, that is 1.5 r. It is mentioned, right? This distance is given as 1.5 r. This distance is given as 1.5 r. So you have to divide this force by 1.5 r. So if you do this, you will have this m omega square r divided by 30, right? So if you put the given values, right, then see here omega square r is given and g is given, right? So omega square r is given as 300. So omega square r is 300. It means it is 10 m, right? So 10 m Newton will be the force at P, right? And it is in the upward direction, right? Let us say this force at P is in upward direction. So if at P we are considering it upward direction, then RQ will be in the downward direction because it is generating this couple. So RQ will be again the same only, this 10 m Newton only, but it will be in the downward direction, right? Now reaction force at P due to gravity will also be there, right? This is G is given, so due to gravity also there will be some reaction force because this mg is acting downwards, so there will be this force, reaction force, which is acting upward, right? So mg by 2 due to this gravity, so I am writing rp due to this gravity. So rp due to gravity will be mg by 2, and g is given as 10, so it is nothing but 5 m Newton, right? So at P it is given like this, and here at Q also it will be mg by 2, so it is 5 m Newton only, right? So here what is going to happen is this particular force will be in the upward direction, right? This force will be in the upward direction. So if you consider the total force at P and Q, then what is going to happen is at P you will be having this 15 m, and at Q it will be 5. So when you take the ratio, it will come 3, right? This ratio will come 3.
So sir, the
Yes,
downward direction net na,
sorry, downward direction.
the reaction at Q, net reaction at Q is in downward direction and P is at upward direction.
Yeah, which is generating couple, for that it will be different, na?
जी सर जी सर.
Mm-hmm. So everyone is getting the same. Hello.
Yes, sir.
Okay. So now this is the question, next question, that the figure shows an arrangement of a heavy propeller shaft in a ship. The combined polar mass moment of inertia of the propeller and the shaft is 100 kg meter square. The propeller rotates at omega is equal to 12 radian per second. The waves acting on the ship hull induces a rolling motion. Here you are having a rolling motion as shown in the figure. with an angular velocity of 5 radian per second. Angular velocity is given as 5 radian per second. Now the gyroscopic moment generated on the shaft due to the motion described is, you have to calculate
0.
this.
Sir,
0.
0, yes. 0.
Correct. So you got it right. It will be 0. Why?
Because
Sir,
in rolling
precision and
because of rolling
are
motion.
same. Precision and
Yes.
spin direction are same.
Correct, correct, good. Because it is rolling motion, and in rolling motion you are having spin axis and precision axis coinciding with each other. So you will have 0 in this case. Correct.
Yes, sir.
Okay, the next one is this one. See, in this one, a massive uniform rigid circular disc is mounted on a frictionless bearing at the end E of a massive uniform rigid shaft AE, which is suspended horizontally in a uniform gravitational field by two identical light inextensible strings AB and CD as shown. Now, where G is the center of mass of the shaft disc assembly and G is the acceleration due to gravity. Now the disc is then given a rapid spin omega about its axis in the positive x-axis direction as shown, while the shaft remains at rest. Right, now the direction of rotation is defined by using the right hand thumb rule. If the string AB is suddenly cut, right, if the string AB is suddenly cut, assuming negligible energy dissipation, the shaft AE will negligible energy dissipation, the shaft AE will, what is going to happen to shaft AE if this AB is going to cut suddenly? So can you try?
Yes, sir, trying.
Okay.
Sir, it will be in a negative direction of Z axis.
Correct. It will be in the negative direction of
Z axis.
Z, right?
Yes, yes.
Correct. So it will be in the negative Z direction. So this is how you are having your this because here you are having this center of gravity here, so it will go towards this negative Z direction if you are going to cut this string, and it will rotate with little bit slower angular velocity compared to omega as mentioned in that particular thing, right? So this is how you are having this gyroscope and some of the examples asked in GATE related to this,
सर
right?
सर सर ये वाला
Yes.
समझ नहीं आया.
See, as you are having this center of gravity here, right? If you are going to cut this, it will try to go down, right? So this is how you are having that rotation in about this negative Z direction, right? If it would have towards this one, right, then it would have gone on the upward direction if the center of gravity would have lied this side, right? So this is how you are given this particular option about this negative Z direction, it is having rotation. Correct? Hello.
हाँ सर, एक बार कोशिश कर रहे हैं. सर मेरा तो वाई डायरेक्शन आ रहा है.
No, 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 no. it will not go towards that direction, na.
एक बार और एक्सप्लेन कर दीजिएगा सर, सेंटर ऑफ ग्रेविटी कैसे डाउन आया, वो तो अप गया ना।
But this what we can say, this AE will rotate about z axis, na. AE will not rotate about y axis, na. What they have asked is what will happen to this shaft AE. Can you see this shaft AE is going to rotate about this z axis only, na. It is not going to rotate about this particular y axis,
हाँ सर, ओके सर, ओके सर,
right.
जी सर।
It will go down, but that is why it is in the negative z direction, right, as you have told, right. It will go down because G is here, right. Got it?
यस सर, यस सर, यस सर।
Okay then, so for today we can stop here. Is there any thing to ask for this session?
Sir, if you don't mind, can you explain the condition of nose and tail, sir?
Yeah, let us go back to that nose and tail simple one, right. This one, correct.
Yes, sir, but and the
Ah,
problem, sir.
in the problem, okay.
Yes, sir.
Let us
Like,
go to the problem also. This one, right. This one, right.
yes, sir. Yes, sir. Did not understand the condition.
See, here actually, as I have told you, see what is happening. Actually, whenever you are having this particular clockwise direction from front, then see, if you consider or what we can say, remember what 4 cases we have discussed. When we are viewing from rear, it will be anti-clockwise, right. Yes or no.
Yes, sir.
So if you remember that viewing from that rear and anti-clockwise and taking a left turn, what is happening. So can you see here again in that standard whatever case we have discussed. So what it lies under which particular case here, it will be this case, right. Viewing from left and counterclockwise, yes or no.
Yes, sir.
So it is the case, right. So
Yes, sir.
if you try to understand from here, what is going to happen when it is going to take a left turn, we will have this as the active gyroscopic couple in this direction, right, and reactive
Yes,
will
sir.
be in this direction. So again what will happen, this particular reactive gyroscopic couple will try to down the nose, right. As you can see, this particular thing, if I extend this, yeah, this is for 1A, right, for 1A and let us say 2B, I guess both are same. Similarly, if you go for 1B and 2A, both are same, right. So 2A, what is going to happen is this particular active gyroscopic couple will be acting in this direction and reactive will be in this direction, right. So this reactive gyroscopic couple is trying to down the nose, right, because in this particular can you assume that this is an axis coming out of your aeroplane and from the plane of paper it is coming out and it is trying to act in this direction for this particular 2A. So it will down or deep the nose. Are you getting what I am trying to say? Hello. 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 Can you hear
Yes,
me?
sir.
I guess I got disconnected.
Yes, sir.
Oh, so again I need to share. You understood? Hello.
Yes, sir.
Once.
Sir.
Yeah. 1 second. Can you see my screen?
Yes, sir.
Can you see the screen now?
Yes, sir. Able to see.
Okay, and whatever I was discussing, have you heard this? Whatever I have told regarding this, or should I repeat?
Once.
Yes, so let me again tell you. See here, in case of this 1A, what we have discussed is active gyroscopic couple is in clockwise direction, reactive is in anti-clockwise direction. So it will try to up the nose, right?
Yes,
Similarly,
sir.
for 2B or this, for 1B or this 2A, 1B or 2A, it is the opposite. It means what is going to,
Excuse,
yes,
sir, that one not it not visible. Only the meat is visible. Meat window.
1 second, 1 second. Now can you see the screen? Hello.
Sir.
Yes,
Yes, sir.
you can see, right?
Yes, sir.
Okay, now can you see this note?
Yes, sir.
Yes,
Yeah.
sir.
Yes. So now what I was telling is here in this particular case is what we have been asked in this that particular problem is this case, right? 2A. So what is happening in this 2A is this vehicle is taking a left turn, and because of that this active gyroscopic couple is generated, right, and which is in the anti-clockwise direction, as you can see here, right. So the reactive gyroscopic couple will be in the clockwise direction, and when it will be in the clockwise direction it will try to deep the nose and raise the tail, because it is about this axis, third axis. Are you getting?
Yes, sir.
So anything else?
No, sir.